Random numbers. A number is chosen at random between 0 and 1. What is the probability that exactly 5 of its first 10 decimal places consist of digits less than 5? Okay, so we're picking a number between 0 and 1. So this number will look something like this. It is 0 point, the first digit I call A, B, C, third digit, D, fourth digit, E, fifth digit, F, sixth, G, seventh, H, eighth, I, ninth, J, 10th. So this is the first one, second one, third one, fourth one, fifth, sixth, seventh, eighth, ninth, 10th. Okay, so 10 decimal places. So this is basically, it may have more, but first 10 decimal places can be seen like this, or visualized like this. Now for each digit, we can have the following possible outcomes. So each digit can have a value 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So how many possibilities do we have for each digit? Well, that's total of 10 possibilities. Okay, so we have 10 possibilities for each digit. So which ones are less than 5 and which ones are greater than 5? So if you look at the first 5 here, 0, 1, 2, 3, and 4, these are less than 5. And 5, 6, 7, 8, and 9, these are greater or equal to 5. So then I ask the question, for a given digit, what is the probability of having a value less than 5? Or I can ask, what is the probability of having a value greater or equal to 5? And since we have 10 possible outcomes and 5 of them correspond to less than 5 and 5 of them correspond to greater than 5, we can say that this is 5 out of 10 possibilities. The answer is 1 over 2. So with 1 over 2 possibility for a given digit, we can have a value less than 5 and we can have a value greater or equal to 5. So capital N is the total number of decimal places of interest. So this is basically 10. So we're looking at 10 decimal places. N decimal places will have a value less than 5. So this is the number of decimal places consisting of digits less than 5. And how many do we want? We want to have exactly 5. And therefore n prime should be the number of decimal places consisting of digits that are greater or equal to 5. And that is also 5. And as you can see, n plus n prime is equal to capital N. So what is the probability of having exactly 5 out of 10 decimal places consisting of digits less than 5? Well, first of all, I have to choose 5 out of 10 decimal places. So in how many distinct ways can we choose 5 out of 10 decimal places? The answer is given by combinations of 10 objects taken 5 at a time. This is 10 factorial, 10 minus 5 factorial, 5 factorial. So that's basically 10 factorial divided by 5 factorial, 5 factorial. So that will be the answer. And now, given that we have chosen 5 digits, what is the probability that all 5 of these digits will have a value, all 5 of these decimal places will have a digit less than 5? Well, for each one, the probability of having a value less than 5 is 1 over 2. So for 5 of them, it will be 1 over 2 to the power 5. So we have chosen 5 digits, 5 decimal places, 1, 2, 3, 4, 5, and each of them will have a value less than 5. So I want this to have a value less than 5, less than 5, less than 5, less than 5, less than 5. So what is the probability of having this? Well, for the first one, the probability is 1/2, second one is 1/2, the fifth one is 1/2. So the probability is 1 over 2 to the power 5. But at the same time, for the remaining 5 decimal places, I want to have them greater or equal to 5, 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 and that has a probability 1/2 for each of them. So this is also 1 over 2 to the 5. So what is the probability of joint occurrence of the 5 decimal places having a value less than 5, 1 over 2 to the power 5, and the other 5 will having a value greater or equal to 5, that is 1 over 2 to the power 5 multiplied by 1 over 2 to the power 5. So basically the answer is the probability of n having a value 5, that is 5, exactly 5 decimal places will consist of digits less than 5, is given by the binomial distribution, the number of distinct ways I can choose n out of capital N decimal places, p to the n, q to the n prime. So that is basically 10 factorial, 5 factorial, 5 factorial, 1 over 2 to the power 5, 1 over 2 to the power 5. So this gives us, for probability of n is equal to 5, a value that is 10, 9, 8, 7, 6, and then 5 factorial, but 5 factorial is going to cancel here, divided by 5, 4, 3, 2, 1, 5 factorial, and then I will have multiplied by 1 over 2 to the power 10. So if you calculate this, the answer is 0.25. So this is the answer to the final answer to the question. Okay, so here you can see that we have 5 and 2 cancelling with 10 and then we have 4 canceling with 8 giving us a 2, and then we have 3 canceling with 6 giving us another 2 here. So you would have in total 4 times 9, which is 36 times 7. So it's 36 times 7 divided by 2 to the power 10, which is 0.25. Okay, so let's summarize what we said here. We are choosing a number with random number between 0 and 1. So this number will be in the format 0.ABCDEFGHIG and other decimal places that will follow. But we're looking at the first 10 decimal places, and we want exactly 5 out of these 10 decimal places to have a digits less than 5. For a given digit, we can have a value 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, so 10 possibilities. And you can see that 5 of these correspond to a value less than 5, 5 of them correspond to a value greater or equal to 5. So since we have a random number, for a given digit, the probability of having, for a given decimal place, probability of having a digit less than 5 is the same thing as probability of having a value greater or equal to 5, which is 5 out of 10, 1 over 2. If we call capital N total number of decimal places of interest, that's 10. We want 5 of them to be consisting of digits less than 5, that is n. And n prime is also 5, which is the number of decimal places that have a digit whose value is greater or equal to 5. And n plus n prime is capital N. So in how many distinct ways can we choose 5 out of 10 decimal places? That's given by combinations of 10 objects taken 5 at a time. And then having picked 5 of those decimal places, what is the probability of having all of them having a value less than 5? That's 1 over 2 to the power 5. And for the rest of them having a value greater or equal to 5, that is 1 over 2 to the power 5. And what is the joint occurrence of both the first 5 that we have picked to have a value less than 5 and the second 5 to have a value greater or equal to 5? So that is the product of the probabilities 1 over 2 to the power 5 and 1 over 2 to the power 5. So that's basically giving us the binomial distribution. So probability of having for 10 objects taken 5 of them having a value greater or equal to 5, 5 of them less or equal to 5. It's given by the binomial distribution, and it's basically combinations of 10 objects taken 5 at a time, p to the n, q to the n prime, 1 over 2 to 5, 1 over 2 to 5, and the end result is 0.25.